So here's a different electrical panel for an Eclipse. This panel happens to be for an Eclipse XL. Eclipse XLs use stepper motors instead of servo motors, and these are the stepper drives. Cutting head Z, Y for the arm, up and down, and X for the arm left and right. Common wiring block here with 0 volts, home switches, 24 volts, 5 volts, relays for making the blade go in and out, turning the brake on and off. These are your connectors for your cutting table. You've got the inputs and outputs like your clamp switch and your emergency stop switch. In the back you've got your power switch. These are power wires going out to the clamp and e-stop switches. This is power for your Z motor, X motor, and in the back the Y motor, home switch for Z, X, and Y, and then back in here is the brake connector power. Over here is ground blocks and high voltage 120 volts AC distribution block. Back side of the circuit breaker, and the name panel. Name panel is always on the end of this big black box above the circuit breaker. This is the interface with the motion controller. This is called the ICM 2900, or ICM for interconnection module. It basically breaks out this high density connector right here into wires, individual wires for individual purposes. Also on the back of the electrical panel you've got the clamp valve and the cutting head valve. On this end we don't have it here, but this is where the air prep system goes, filter regulator, lubricator. Now I'm going to take this electrical panel and I'm going to upgrade it to a pro electrical panel for servo motors, and I'll show you that along the way. Basically we're going to replace these drives, change some connections over here, put in an emergency stop relay. We're going to remove this connection panel and we're going to put in a DIN rail, which is this gold with individual connectors. We're going to add a couple of back EMF resistors here and a couple of connectors here for 48 volts DC. This is the power supply. If I didn't mention that, this is the power supply that supplies the power to the drives. It has a connector back in here. If I unplug this power AC cable, you can see this connector back in here, and it has 5 volts, 24 volts, and 48 volts on it. There are individual lines that come out of the power supply back here and go to each one of the drives here. What else can I tell you? There is a fuse right here for the power supply. You have to stick a little screwdriver in here and flip this out. Let's see if I can do it. I can't do it with my finger. Yep. Stick a little screwdriver in here. And get this to come out. Oops. So once you get that out, it's got a little fuse in it. Slide it back in, push it in until it locks. There's a switch back here for the red switch right here for 115 or 230 volts. Alright, so I'm going to get to remodeling and I'll get back with you later. While we're talking about an Eclipse XL versus an Eclipse Pro, let's look at the wiring on the ICM 2900. If you notice, these say like X latch, the labels. Let me turn this label. See how that label says X latch, Y latch, Z latch? Well, these are also known as input 1, 2, and 3. Now there's an input 4, which is a W latch back here, and you can see on the other side we have inputs 5, 6, 7, and 8. So these three have dual names, and they're input 1, 2, and 3. The home switches are here. That's normal for Eclipse Pro or XL. Outputs, output 2 is for the cutting head, and output 6 is for the brake. Now we have amp enable X, Y, and Z, and that's for turning on each of the drives, whether they're stepper drives over here or servo drives like we're gonna put in. Now, one of the key things is down here we have in a servo we use this first terminal, motor command Z, motor command X. Same over here on Y and W. W is there for a 4-axis machine. We don't have a 4-axis, we only have 3. Now in a stepper we use signal Z and PWM Z, and one of these is direction and the other one is step. So one of these lines is held on high for going forwards and low for going backwards, and or vice versa, and the other one is a series of pulses that tell the stepper motor how many steps to take, or how many counts basically to move. We'll talk about that more in detail, but I wanted to show you the wiring difference in that a servo motor uses this first one and the ground. In an analog servo drive we don't use this ground here, but in a digital servo drive we do. And then this is your step and direction signals for your motors. So each motor has 2 lines that control it. All right. So on these stepper drives, we need to talk about how to get these headers unplugged. Now you can see the headers are divided into sections. It looks like 2 sections, one here and one here, but each one of those sections is actually divided into 2. You can see the split line right there. All right, now you can see that these circuit boards on the drives have these pins, and those pins go in these holes right here. So there's also a groove on the back, and that goes over this black bar that's back here with the pin sticking out of it. So we take to put them on, you just push them on, and they got to cover that bar so they're not sticking out. I've seen people stop like right there and they're not completely on, they're not completely in, and you can still see that bar right there, and you need to push them all the way in like that. To get them out, I use this screwdriver and I just carefully pry them out, and then you can use your fingers and wiggle them off just like that. So use your screwdriver and pry on the connector like that, and they'll come right off just like that. Okay. All right, once you have the connectors unplugged, to change the stepper drive out is very simple. There's two screws. There's a screw way back in here, Phillips head screw, number 2 Phillips. Just take that screw out. And then there's another screw right here at the top. You take that out. Just like that. And then this angle bracket, you can see the stepper drive is bolted to the angle bracket. So let me see if I can do this one-handed. All you have to do is take 2 of these screws out. See that screw right there? And then loosen this screw and loosen the other screw. And then this drive slides right off of there, and then you can put the new drive on and put it back in place. Okay. One thing you should know about these drives is they're universal. So just because this one's got a white X on it, somebody painted that on there. There's no reason to do that. This drive right here is exactly the same as this drive, exactly the same as this drive. The only thing that makes these drives different is the little resistor that's right there on each connector. So it's the connector and the header with this resistor that makes the drive a Z or a Y or X. It is not the drive. Okay.